Man, late to his own game.
What's up? Where are you at, Ben? You look like you're in a studio.
I'm at work. It goes back a while. And I'm on the top floor. You see it?
Where do you work?
Northwoods Church, community church.
Oh, okay. That's real close to my house. Virginia and Justin, are you here?
Yes.
No Brenna?
I heard my name. I was in the bathroom, but I'm here. Give me like 2 minutes and I'll actually be present.
Courtney, you gonna be here?
No. Did you ever figure out who that is?
No, I didn't.
That's somebody's friend?
It wasn't an administrator.
Not that I'm aware of.
That was pretty fun, I'm not gonna lie. It's like, well, I'm gonna go cry over it.
It's gonna work just fine. You guys were with Brennan this morning, weren't you?
Yeah, I was.
And she didn't say anything about not being here?
Nope.
Okay. Okay. Well. Try something. If I do this, I'm gonna have to figure out a way to show you the teach pendant, and today we won't need it. But. Okay, so this class is Electech 231, and got just a blackboard. Everybody right now is getting Fs. Good job.
Nice.
Solid.
Show you where the syllabus is at. Course information, right yonder. First thing we'll get into are these FANUC robot labs. I haven't really decided on a schedule yet, how to handle that. I'm thinking that we might do like Monday's lecture Wednesdays and Fridays lab. Technically we have 4 robots, and 3 of them should be usable. 2 are usable right now. So start off with, when we only have the robot labs assigned for you guys to do in this class, it's going to be hard to spread out time so everybody has a time slot to do that. In the past, we've done things like schedule lab time, but then when we add the whole Zoom thing in there, I'm going to have to get kind of creative. So I'll have all that figured out by Friday's class. But, we're going to start with the robotics because I want you guys to have labs to start working on. And then there's going to be some lectures about motors and drive systems, and there's some math involved with that. And then towards the end, we'll get into CNC stuff. So you'll have plenty of time to get all these labs done. It's all done either on these robots, or then we have some CNC trainers in the back of the lab here at AIT 217. So that's just a little heads up about how all this is going to work. On Blackboard, the PowerPoint that I'm going to go through today, or start to go through, will be helpful for you guys, and that is under course content, FANUC robot guides, and there's only one PowerPoint in there. This is it. If you were to download this, then you would see this PowerPoint. I'm not going to make it a long day today since it's the first day, but I want to familiarize with you guys with these FANUC robots. Any of you worked on or near or around or with robots? Anthony, Ben, a little bit. What did you guys work on with them?
There was one of them when I was at Caterpillar that basically lifted up a panel, a plate that was put into a shot blaster, and basically what it would do is pick up a new plate, put down the old plate, and then basically add more material into the shot blast so that it will go through the whole process, and they'll just keep doing it over and over again. Another one was with in the machinist side that was picking up different materials that was being crafted from the machines and then putting on pallets so they could be shipped out to different companies.
Okay. What about you, Ben?
I was at, I forget where it was, but this robot was taken apart and putting it into a lathe, waiting for it to finish. Then it would take it out, and then it would have it put into another place where it got deburred, and then it was put onto another line of assembly where it got pushed into more and more, fine-tuning it until they, shipped it out or whatever with it.
Cool. They're kind of cool, aren't they? I mean,
they're really cool to watch. It is really cool.
But neither of you got into any of the programming?
No.
Okay, so that's what we're really going to do here. And I know you're just staring at this teach pendant and not my face right now. Hi. In this class, primarily, I'm going to teach you how to program. There's just a lot of, I don't know, it's kind of a whole different world. You have to understand coordinates and points relative to other points and different motions and instructions and inputs and outputs and all that stuff. But it can be pretty fun, and you guys probably are going to be somewhat natural at it because we're in the age of video games and all that stuff. But they are fun, but they are also very, very, very expensive. So Um, so what you're looking at is, do you guys think this thing is smart?
Extremely dumb. No.
No. No, these things are really, really dumb. They're only going to do whatever I tell it to do. So like in this case now, if I told this thing to go down in the z-axis at 100% speed for 3 feet, what's it going to do?
Go through the table.
It's going to jam itself right through this table. Now it does have collision settings in it, so it will detect and shut itself off if it's supposed to go this way. You know, I don't know what that is.
I've not specifically worked with Phoenix before, but we use an arm, robotic arm, and if it would sense where it was, and if you programmed it to do it, it wouldn't even let you type it in.
Yeah, and that's another thing with the program, and we'll get into that too, but there's motion instructions. So if I want it to get to this point, and I want it to go in a, you can either tell go in a straight line that way, 6 feet. You know, it's not going to do that because it's going to say, hey, brah, my butt's in the way of that. I can't do that, you know. But I guess what I'm getting at is it is fun, but don't get too out of control with, you know, messing around with it, because people can get hurt too. Like it's, if I tell it to swing in a circular motion this way around the table at 100% speed and somebody's standing there, somebody's gonna get pretty hurt. So it's gonna be fun, but take it seriously too. But there are, like, there's a program, I don't remember, it's probably the other one. There's the other robot right now has a suction cup mounted to it. So there will be one program that you guys have to write where you pick up this ping pong ball, move it over here, go pick up this ping pong ball, move it over here, in like 4 different arrangements. So I enjoy it. It's fun, it's challenging. Yeah, that's all I'll say. But I think what I'm going to do is do the whole Google Drive thing. That seems to work pretty well with you guys. So, Virginia, are you there?
I am. Can you hear me?
I am. I can't.
Okay. I'm cutting in and out, so I'm not sure how.
That's okay. I just want to set up a Google Drive for you guys for this class, because there's another PDF that will be useful for you guys. It's this one here. It's basically the users and maintenance manual for this robot, but it's a couple, I think it's over 1,000 pages long. So to put it up on Blackboard, you guys would be downloading it every day and blah, blah, blah. And Blackboard charges the college for memory space. So it's just easier for me to share these things with you guys on Google Drive. So what I'm going to do is make a folder. Some of you guys were here yesterday. I did the same thing, but where are we at? 22 on the screen. Anthony, is this one you? 354A?
Yes.
I'm assuming this is Ben, is this right?
Yeah, that's mine.
I think this is Brent Dwyer. Justin McGowan. Justin, you're JM885B.
Yep, that's me.
Virginia, do you know your user ID? Should be VO.
My future ID?
Yeah, your @lab email address. Should be VO something something.
Oh, VO028 at lab.icc.edu. Yeah.
Here we are. Okay, I just shared this folder with y'all, all y'all. And this file that says handling tool setup, it's going to take a minute to upload, but what I was going to tell you guys is with these labs, I know Brenna's not here right now, but I am recording these lectures. So I will put those up on YouTube and I'll put them in a folder within this shared folder. So I'll say lecture videos. Okay, and in this folder in the future, like I'll put this on there. So if you're going through these labs, you have a reference to go off of, because I think I'm a pretty laid back dude, right? But if I go through this and I go through step by step and tell everybody this, this, and this, and this is how you do this, and then somebody sits down at this robot, grabs a teach bennett and says, hey, how do you do this again? It's like, come on. I just told you how to do all of it. So my point is I'm not irritated, but I don't want to have to teach this 5 times plus lecture. So you have a manual and you have, you'll have these videos of me telling you how to do this stuff as a reference. And that's not to say that I won't help you, or if something doesn't make sense, you can ask, absolutely. It just gets under my skin just a little bit when I have to reteach you something that I just taught you. That makes me sound like an a-hole, doesn't it?
A little bit.
A little bit? All right. I'm sorry about that. Thanks for in all seriousness, like I am here to teach you and here to help you. But if you're not taking notes or if you're not paying attention, that's not my deal. So anyway, I also want you to get in the habit of problem solving for yourself, because you know, if you have a job servicing robots here in a year, like, yeah, you guys are always welcome to call me about something, but you're not gonna be able to call me every time you got an issue at work, right? You're gonna have to cut the cord a little bit and go after these problems on your own. So now that I'm done being an a-hole, I guess we'll start looking at this PowerPoint. Scooch this back a little bit so you can see the different parts. And you all can see the PowerPoint and you can see the robot, right?
Yes, we can.
Thank you. All right. This PowerPoint is really all about programming. We're going to talk a little bit about what makes these things work later on. Right now, you should have some kind of an understanding of, well, you definitely should have an understanding of motor theory, right? How current makes a motor shaft spin. And these things use what's called servo motors. Do you guys know what a servo motor is and why it's different? Anybody? Okay, well, a servo motor is typically a DC motor that also has feedback. So there's some kind of controller that comes along with it that will tell, it'll tell the controller where in the rotation that motor is at any given time, right? So if I wanted this joint of the motor to spin 6 degrees clockwise, something's got to tell that controller how much it is spinning, how much it was spinning. That's what a servo motor does. So we'll get into all that theory kind of stuff a little later. We don't have a lab work cell. We just have robots. Conveyors. These things are designed to help keep people safe. I'm just kind of trusting that you guys won't spin this thing around like a frickin' hula hoop and get somebody killed. I can trust you guys, right?
Yes, sir.
Yes, Zach. Okay. Thank you, Virginia, for chiming in. All right, this is what the controller looks like. I'm not going to spin this whole table around to show you the front of it, but it looks exactly like it does in this picture. On this setup, it is over here. So on the front of that door, you have the same components as you see on this picture. There's a toggle switch. It looks like a circuit breaker, but all it is a toggle switch. That's the main on and off for it. And in order for any of this stuff to work, any e-stop on this thing or on the teach pendant, which is what this thing is, this is what I use to communicate with the controller. But you see there's a little e-stop up here. If that thing is pushed in, nothing's going to work. And it will give you a little error code up at the top that says teach pendant e-stop is depressed. So to undo the e-stops on these, it's one of those twists and it'll pop back out. This little auto T1 switch we probably will not mess with in this class, but if I wrote a program to do something like palletized boxes over and over and over and over again, and I was going to run it in auto, that's what I would use this little switch for. One is used to jog, and then the other one is I'm going to run through these with you, even though I've already got it powered up. You can use this PDF. Let's say if you guys come in Friday and try to do a lab, which I think after today you should be able to do the first one. And sure, the applicable circuit breakers in the main electrical panel are in the on position. Well, that's out in the hallway. No, that's actually over by the ladders in this lab. But trust me, the circuit breakers are on. If nothing will power up, we might have to check that. The auto T1 key switch is set to T1. We're in the jog mode. The disconnect toggle switch is on. So that's saying this stuff. So here's the key switch, put it on T1. E-stop is pulled out. On-off toggle switch that's already all done. You can hear the cooling fan controller. View the display on the teach pendant as the controller runs through its power-up sequence. Takes approximately 25 to 30 seconds. All right, and we'll do that together. I'm going to power this thing down and power it back up so you can watch and see what this teach pendant does. Coming hot! That didn't make any of you like giggle at all. You guys are boring.
Ha 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 ha.
I laughed in mute.
Could you zoom out just like a teensy weensy bit? Because it's the letters are, it's hard to read what it says.
That better?
No, because Ben's face is now frozen on my screen.
Yeah.
Oh, fuck.
Oh,
Okay.
are you on? Okay, so on Zoom, if you scroll, kind of put your cursor on my video up towards the right, you see the little 3 dots in the blue square.
Got it.
Click on that and then go pin video.
There it is. And yeah, it's just kind of blurry. I don't know if it's just going to stay that way. Zoom back out a little bit. Oh, wait, no. Yeah.
What if I did? Does that help?
Yeah, that's good. Thank you.
Really, there's nothing here to look at. It's just telling you, hey, this is my version and my brand, and this is my rifle, this is my gun, kind of thing. Anybody know what movie that's from? This is my rifle, this is my gun.
Yes, I do know where it's from.
This is for fighting, this is for fun.
Yep.
Thanks for credit, Justin. That's what I'm talking about. What's the movie? We got to name the movie now before I give you an extra credit.
Oh, Jarhead.
Oh, I guess it is in that movie, isn't it? I was thinking.
Full Metal Jacket.
Full Metal Jacket. Yeah. It was one of them. It's both of them, but actually.
How tall are you, Private? Let me see.
I believe it was like 5'4"
5'7"
or 5'8", and it's a shit. I didn't know shit you could stack shit that high.
I didn't know they stack shit that high.
Wipe that smirk off your face. Can you do that one, Zach? Do you know that one?
That smirk off your face?
Yeah.
Is that the drill sergeant saying that?
Yeah.
What does he say?
It says, wipe that smirk off your face. And he says, I'm trying, sir.
Trying, sir. Yeah, and then he kicks the crap out of him.
Yeah.
Yeah, that whole movie is kind of disturbing. That's all right. Okay. What are we doing? What about robots? Okay. Are you with me? No? Okay. Oh, thumbs up. That's what I'm talking about. Oh, I guess I got through the thing. We're powered up. Reset the emergency stop buttons on the pendant and the controller by twisting the button until it pops out. This allows electric power to flow through the robot. Reset all the faults on the pendant by pressing the reset key. There is an error in there because this will not reset unless you're pressing the dead man switch. It's still not telling you where it is. There it talks about it. Down here at the bottom. Dead man switch on the key pendant must be depressed along with one of the 2 shift keys. I'm going to go back up and try to reset that fault. Make sure there's not anything going on with this here robot. But I'm gonna zoom out and show you where the dead man switch is on the back here. There's these two little reds, two little yellow switches. Either one of these will work for using this, but if I was gonna jog the robot, you have to depress these while you're making any of it move. This is called a dead man switch, and there's two positions. If you're halfway in, and you're okay to use it. If you push it all the way in, so there's a third position, then it will stop. But anytime I want to move the robot or run a program, you have to have this halfway pushed in. Okay, this is called a dead man switch. Typically, people are right-handed, so what they'll do is hold this thing with their left hand. It's got a little strap on the side here. Okay, so I got that going through, and then on the back side, you'll hear it kind of click. I just pushed in that dead man switch. So I've got that halfway depressed, and then you see this little red part up here. I don't know if you can read it or not. It says fault. It's giving me some kind of an alarm. I'm not sure if that will clear out. I'll check that in a second. But to reset it, you have the dead man switch pushed in, and then you hit, here's the reset button right here. Reset. If everything's good, this will go away, and it's not. So why are we getting an error? Deter alarm. Let me try this. Function abort all. Oh, because I don't have the damn thing plugged in. Oh, give me a break. Seriously. So I had just so you know, the third robot in here. We've never had it running before. It just got donated, but it's having some issues that I'm trying to work out. So just for this class, I wheeled in one of our newer ones and fired it up, assuming it was just going to take off. I'm already having these deter alarms. So right now I'm trying to see if I can find a quick fix. Right. So just so you know, before when you're seeing this little red doohickey here, that was a fault. And it's going to tell you some kind of code, and it says dead man switch is released. So it's telling you, hey, I'm not going to do anything because you don't have your damn finger on the dead man switch. So I'll depress it, hit reset again, makes the fault go away. Now at this point, I can jog the robot. You know what jogging means, right? Just moving it to whatever position you want to. Same way you would jog a motor, or you're moving something manually. All right, teach parent primary operator interface for the handling tool programming software. Displays various menus, blah, blah, blah. Right, blah, 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 blah. Here's what it looks like. This actually is a picture of the robot I was telling you earlier. It's a little older style of teach pendant. It's not like the one you see on my screen right now. But all of the functions, the programming, the buttons, for the most part, are all the same. The only thing that the one on my camera does not have these little indicator lights. Like on this picture on the left-hand side, you see little indicator lights. It does not have those here. The indicator lights, there's only 2 of them on this one. It's power and fault right here. All the other things are going to be displayed on this teach pendant up here at the top. It's going to give you your error codes. It tells you if you're in step mode, or which we'll talk about later, and all that stuff is given right here. And this is basically what we're going to use to control the robot, use to jog the robot, create programs, run programs, all that good stuff. It's like your controller for your PS5. You know what I'm saying? Who has a PS5? None of you?
Nope.
Good grief. This is the most boring freaking class I've ever had. Come on, wake up. Who has an Xbox?
I do.
What kind of Xbox?
I have one.
One.
What?
Xbox One.
Xbox One, is that the newest one?
No.
The Series X is the newest one.
Series X? I have a Nintendo Wii.
I've never played a video game in my entire life.
Come on, you've never played Mario?
I played it on Wii, like with the steering wheel, but I don't think that counts as a video game.
What?
It does count a video game.
Come on. Pac-Man, you never played Pac-Man?
I've never played a video game, but I've played Mario Kart, Mario Party.
Yeah.
Those are all
I've never played a video game in my life, but I am a level 30 on Halo 2.
I have the one right before the Series X. I think it's the
360?
no, it's the one. I think it's the 1S.
Xbox One.
Yeah.
That's like the second from the first one, right?
Or it's the
I've never played a video game in my life. My players are 95.
What?
he's talking about 2K.
So now,
Oh man, sounds like a robot. What he was trying to say is, I don't play any video games. My career player is a 95 overall. Me and Justin were talking about that one day in Bob's class.
Oh boy. All right.
The 1S is what I have. The Xbox One S.
Where'd Justin go? He gone.
There you go. So you.
So this is the older style teach better. You can see on the left here, it's got all these indicator lights. This is what the one, you'll see what I mean. There's an older style robot that has a little bit longer reach, but also uses older style teach better. Whether you're using, doesn't matter which robot you use, all the principles are going to be the same. And then here are the buttons. From the blown up view of what I was just doing. The dead man switch behind the thing you can't see obviously, but the reset button is right here. That's the one you use to clear out the ball. Anytime you pick this thing up and you want to move the robot, you're going to have to reset the ball, right? Because anytime the dead man switch is released, it's going to fall and not let the robot. Okay, now it's going to tell you about these things called menu maps. These menus on here are difficult to navigate, and you'll get the hang of a few shortcuts to get where you need to be. But there is an appendix. I don't remember which PDF not on there, but it's just a way for you to see if I need to get to this place. I remember where it is. I don't remember how to get to it. That's what these menu maps will help you do. Jogging the robot, we already talked about. In order to do it, the teach appendix must be on. The auto switch must be set to T1, jogging. That means switch halfway down along with one of the two shifts. Shift key is normally pressed. The thumb of the hand is used to press the dead man switch. Dead man switch, blah, blah, blah. I already told you that. These three things are going to affect the way that the robot jogs, the axes that move while jogging. Are you guys familiar with the Cartesian coordinate system?
I haven't done it in 3 years, but.
Well, that's what we're going to use to communicate with the robot where the end of the tool is. So let me rotate this around. All right. So remember, help me remember these things, these three things. Dog speed, coordinate system, computer axis. Got it? Good. I'm going to unshare my screen. I can blow myself up and see what I'm showing. Okay, each minute. See the little red piece there? It's a fault. So to reset that, hold the dead man switch down in the back, halfway down. Reset button. You see that fault go away. To jog, to move the robot, these blue keys over here on the right, you're going to see 6 sets of 2. Those are going to tell you which axes you're moving the robot on. And depending on which mode you're in, they will move the robot in different directions. Right now, I'm in joint mode. So if I zoomed in on, you can see in that little black square, it says joint. What that means is that when I move this top X minus X1, it's going to rotate the robot along joint 1. One way is clockwise, the other way is counterclockwise. So joint 1 is this guy down here. So if I want to move the robot, anytime I jog, I have to hit shift and then move it. So right now it's hard to see, but it is moving. All it's doing is everything up here is staying still, but along this point right here, the robot is moving. It's spinning like that. I'll bump the speed up so you can see it. But I'm going to go plus X. See it moving? Minus X. plus y, so joint number 2 is going to be this. That means this and all the other joints on here are going to stay the same. And the only thing that's going to move since I'm in joint mode is this joint right here. And it's joint number 2. So here's plus y minus y. You can see when I do that, it keeps the orientation of the tool the same. See how it's kind of plumb? So I guess these joints are moving however they need to keep this thing oriented the same, which is straight down. Right now, this thing's got a gripper on it.
I have a quick question.
What's up?
So in the last time I used a robotic arm, you could jog it to a certain location and then mark that and then program it on that mark. Can you do the same thing there? So if instead of finding all the coordinates for it, can you just jog it to one place and then jog it to another place and have it travel from there to there real quick?
That's exactly what we're going to do. So
Sweet.
In your assignments, you're going to be told to come over here and pick this thing up with the gripper, right? So you're going to have to write a program one point at a time. We won't get into that today yet. Right now, your first lab assignment is just to jog the robot using joint, world, joint and world, I think, modes. But yeah, from this point in the program, I would have this point right here. Then I would tell the robot to go in a straight line and hover over this thing. That's point number 2. Go down. That's point number 3. Close your grippers. Point number 4. Lift up. Point number 5. Go over here and do this. Everything has to be spelled out sequential. Now, there is a way that if you want it to be super accurate, for instance, if I had a pen in here and I wanted to draw a straight line on here that's exactly 3 inches long, I could program those specific coordinates in there to make it exactly 3 inches long.
Right.
The easiest thing is whenever I go to a certain point and I record it, so on this, it's saying shift record, you're putting that point into the program. It's actually logging the coordinates of exactly where this thing is. And what it uses is the Cartesian coordinate system. So I don't know if you remember what that looks like, but if you remember from like algebra class, remember you had like an X and a Y?
Yeah, and then the Z is...
So Z is going to be this three-dimensional axis right here.
Mm-hmm.
So Z in this case would actually be going into the wall. What this guy uses, and I'll show you world mode here in a second when I'm done showing you all the joints. World is the easiest, in my opinion, way to navigate, to maneuver this thing from one point to the other. Because world is referenced to this base point right in the middle of this thing. X is oriented plus X in this direction. So I always think of where the plug on this thing, which you can't see it from the back, but the wiring harness that goes into this thing goes in the plus X direction. Y is going to be this way, and then Z is straight up and down. I'll show you that in a minute. But that's what I mean by Cartesian coordinate system. You can...
So basically, you're looking at it from a top view, almost. Like if you were to look at it from up here, it'd be X, Y, and then Z.
Yeah. Yeah. And you can change all that up. You can tell it, hey, I want X to be, going like that. I want Y to be whatever.
Right.
But that is default. So I'll show you worldview in a second. But you can say, there's the waves. In your program, if you record a point and then go, there's some menu options there that will tell you this is X, Y, Z, and yaw, pitch, and roll, which I'll tell you in a second what yaw, pitch, and roll. But then you can say, I want to record a point the exact same, except I want you to do the math and say the Z position, I want it to be minus 3 inches from whatever it is, that next position would be exactly the same, except it would be down 3 inches. You know what I mean? So you can be that precise. All right, so we went through, I think all I've shown you is X and Y, right? So I'm going to go to the Z. Z plus is joint mode. This is plus X is this, plus Y, this joint here, and then if I go minus Y, that brings it back up along that one moving joint. Z is going to be this guy, so that's plus Z. You can see how that just lifts the arm up and down. And right now I'm at 50% speed, just to show you like this thing can go kind of scary fast. Right, so I mean, it's not like frightening, but you can't hurt somebody. Anyway, okay, so that was X, Y, and Z. For joint mode, that's joint 1, joint 2, joint 3. Now we're going to get into something called yaw, pitch, and roll. Yaw is going to be this joint, pitch is going to be this joint, and then roll is going to rotate around this tool. So there's a total of 6 different rotation points. So I'll do yaw right now, it's plus X. You can see how it moves along that one joint, right? If you have trouble seeing what it's doing, let me know. It's hard to tell. So that's yaw. This is pitch. Then this is roll. Got it? So that is in joint mode. I'm going to move this thing so you have an idea of. Now I'm going to move this to world view. To do that on the teach method. Inside this black box, remember I was just in joint mode. I'm going to hit the coordinates button, which is down here. And when I hit it, see how it moves to jog form and then world. World is like my favorite deal, okay? Because it's easy to see where, in relation to the base of the robot, you're taking this thing. So, if I told you that plus X direction in world view is coming away from the base, basically towards you right now, if I hit plus X, it's going to be kind of hard to see, but this thing should go in a straight line, perpendicular with the edge of the table, whoop, whoop, straight to you. So I'm going to do that now. See if you can even see it, but the Y and the Z direction should be pretty easy for you to see. Set, hold nodes. Plus X should come straight to you. See that? It's going to move all these joints simultaneously, however it has to get this to go straight in that plus X direction. Make sense?
Mm-hmm.
All right, this is minus X, so it's going to go straight back. And then to show you, let's see a little bit of the table. Plus Y, I think is that way. If not, it's this way. Here's plus Y. Oh, coming at me. That's plus Y. This is minus Y. And you can kind of get a sense that it's it's not swinging around this way, right? It's going in a straight line, pretty much parallel to the line of the table line. Then Z is going to be straight up and down. See how it follows that axis? Yeah? Why do you think this is my favorite, or why do you think this is the easiest to, when you're programming? Thoughts? Well, what if I wanted to pick this thing up? Do I want to do it in joint mode? If I have this thing right underneath the gripper and I want it to come straight down, I put it in joint mode, I'm going to have to move this joint and that joint and then adjust this joint for the pitch, right?
Right.
So let me show you the joint me going to pick this thing up. I'm going to put it back in. Hey, Brennan, can you mute your mic? We're hearing a bunch of wind. Thank you. All right, so I'm in joint mode. I'm going to do the best I can to go straight down and pick this thing up. So I'm going to rotate here. There. And I have to adjust here, here, that. One joint at a time, it kind of sucks. You can see that, right?
Right.
But I'm going to put myself back up there. Now, if I'm in world view and I just hit the -Z button, it's going to go straight down. Well, got it. Now, and then I'm being a smartass, but in all reality, what I should have done is gone and gotten close and then slowed the speed way down so I could be kind of surgical about it, right?
Can you program a home position for it?
Yes. Yeah, there's a home position which is not defined in here right now, but then there's also something called position registers. So you could say, hey, go to home position, like you're saying, probably thinking about already, is you might have a home position that's something like right there, right? It's kind of right in the middle of the workspace. So you could write a program where you could have it come over here and do some work over here on this side of the table. And then instead of defining or jogging it to this point, you could just say, hey, after you're done with this stuff, go to your home position. It will automatically know to go right here. And you can define the home position to whatever you need. Make sense? That is plenty for the first day. It's enough to get you started on lab 1. So Friday, let's plan on coming in on Friday. Okay, we'll talk a little bit more about jog speed and motion instructions, and then if some of you desire, you can get started and play around with these things. All right, so I'll see you here in AIT 217 on Friday.
Sounds good.
All right. Brenner, are you still there?